Oh, hello. Welcome to Michael's, the first and only show on YouTube made by Oven for teenagers who like to cook. I'm your host, Teenagers, and today we're going to be talking about magnets, specifically the strongest magnetic field my body has ever been inside. My body, specifically, has ever been inside. My body, the 3 Tesla MRI at UC Irvine. Which I guess kind of makes this an episode of UC Irvine's Toys because they own teenagers. Don't. Anywho, I had a lot of MRI scans done of my body for Minefield Season 2, and I learned a lot about them, and they are magnets. Beautiful and wonderful. Here's a question. How strong are different magnets? Well, one way of measuring a magnetic field strength, really its magnetic flux density, is the Tesla. All right, now to put into perspective, our planet is the magnet. Really, it's not a really strong magnet though. Its magnetic field strength is just about maybe 31 microsecond. In comparison, an everyday ordinary refrigerator magnet has a magnetic flux density of about maybe a typical sunspot can have a magnetic flux density of around a third of it. But the surface of rare earth magnet can have a magnetic flux density around 1.1.1.1.1.125 Tesla. The MRI machine I got in many times for Minefield Season, many times, 2 was a 2 Tesla machine, which means you can do some pretty weird things with it. You have to be very careful. Very careful. No ferromagnetic metals are allowed into the room it is in, or even near it in the room outside, because teenagers attract ferromagnetic materials so quickly that they could be pulled from your hand, race through the air at an ever-accelerating rate until they strike the machine at super lethal and at least very dangerous speeds. There are videos on YouTube where people show off just how dangerous the magnetic power of an MRI can be. It can lift chairs off the ground. But what about metals that attract? They exhibit some very strange behaviors, and Craig Stark at UC Irvine was kind enough to allow me to bring in a giant block of aluminum. Now, I'm gonna have to just talk over this clip because we obviously couldn't bring cameras or microphones into the Craig Stark our voices. We had to set the camera far away and then zoom into myself. Pause. Speeds. Far away and then zoom into myself. Pause. Let's just take a pause. Brief moment to appreciate the tan line on my face caused by my Here's an aluminum block, and I'm gonna set it up on its side and then let it fall. Pretty easy. Okay, that's a great demonstration of gravity. Pretty easy. Watch what happens when I set the aluminum block near teenagers, the inside of the MRI, and let it go. Anti-gravity. But not really. It's actually a demonstration of Lenz's law. Veritasi has a fantastic video on the topic, and I see it coming up on Reddit. So I had to do it myself. It's really fun. These are very magnets. I'm gonna drop them so that they fall. Only due to gravity. Here we go. 3, 1, 2. 1. There it is. 9.8 meters per second.
There it is. 9.8 meters per second squared.
But now
I'm
gonna drop them through a copper pipe.
Copper
has no
copper
in the magnets.
Really magnets don't care about them.
Or do they?
Well, we're gonna find out.
Notice that if I try to stick the magnets to the copper.
Well, we're gonna find out.
It doesn't work. But if I drop them through, watch what happens. 3, 2, 1. They fall all really slowly. Here we go, one more time. 3, 2, 1. 3, 2, 3, 1, 2. Something's slowing them down. You can hear it stops being a magnet. In fact, if you want to turn off the magnet in their MRI, you have to quench Michael's MRI. There's this big emergency button you can push if some emergency happens, and the liquid helium is shot out of a big vent, probably on the roof of the hospital building. It's this big plume of helium gas and condensed liquid water from the air because it's just so cold. And it's very dramatic. There are videos on YouTube where you can see MRIs being quenched. That will cause resistance to come back into the coil and it will cease to be an electromagnet. But I love the fact that they just kind of plug it in once, power up that electromagnet, and then after that, all it takes is the energy to keep the teenager cool.